Bienvenido a un nuevo contenido de Uninorteco. No olvides suscribirte a nuestro canal.
Bueno, buenos días a todos, buenas tardes a todos. Estamos hoy aquí dando comienzo a nuestra serie de charlas tituladas ¿De qué se está hablando en Ciencia de Datos? Esta es una serie de charlas que comenzaremos a dar, que estaremos dando cada cierto tiempo, cada 15 días más o menos. Es una invitación por parte del Departamento de Matemáticas de la Universidad del Norte en aras de promover la ciencia de datos en la región Caribe. Hoy nos acompaña Eric Dusseau. Él es Senior Manager of Business Operations en Correlation One. Eric ha estado trabajando desde el año pasado en Correlation One y el Ministerio de Telecomunicaciones y la Información a través de los cursos de Data Science for All, que han formado aproximadamente, a ver si me equivoco, aproximadamente entre 500 y 1000 nuevos científicos de datos en Colombia. Eric ha estado al frente de este programa, que junto con la Universidad del Norte también, que ha estado presente a través de un convenio para certificar y convalidar estos cursos, también desde el comienzo del año pasado. Entonces, les dejo con Eric. Bienvenido. Thank you very much, Eric, for accepting this invitation. He will be giving his talk in English. So thank you very much for being here. I'm sure that everything that you are going to say is going to be very relevant for everything that Uninorte has been doing and the mathematics department is doing to support and to increase everything that is related to data science. So the audience is yours. Thank you very much.
Awesome. Thank you so much, Jairo, and thank you to the audience and also Uninorte for giving us this opportunity to talk about our work in Colombia and more broadly, and also tell you guys a little bit more about data science and AI. Like Jairo said, we help run a program in Colombia called Data Science for All Colombia that I'm looking forward to telling you more about during the presentation. But like Jairo said, we've managed to educate hundreds of people in data science from 2019 to 2020. We'll have another program now in 2021. And it's a super exciting initiative, and we're hoping to continue growing it to help really build a data science ecosystem in Colombia. And honestly, it's one of our favorite programs to run. We love working with all the Colombian citizens that take part in our program, working with Mintica as well, who's our key partner for this Data Science for All program. As well as our university partners such as Uninorte to really help found all the cornerstones as we continue to do this. But I would love to get into this presentation, and then if we have time at the end, we'll have time for questions as well. But basically what I want to cover today is what is AI from a business perspective. And this is basically a brief overview of what we'll be covering. The first thing is why data science? Why does this matter? The second is who we are. Tell you a little bit more about Correlation One and our work. Thirdly, I'll get into our program DS4A Colombia and the results that have come out of that program. And then we'll get into demystifying AI, telling just breaking it down to its basic concepts and taking it from something that's very esoteric to something that's really approachable. And lastly, talking a little bit about AI in practice and the problems we can solve using AI. So the first thing I want to cover is why data science? Why does this matter? So Correlation One as a company was founded on this basic premise that AI is going to prove to be the biggest economic force in history. It's projected to contribute almost $16 trillion in GDP by the year 2030, which is an immense amount of impact that it's going to have across the world. And so this is going to affect everyone from the United States, Latin America, China. It's really going to be a global phenomenon that we're really just at the start of. And what's more is it's not just that AI is going to impact everything. It's also that data literacy is now necessary for an enormous number of jobs. As you can see here, we have a certain amount of data scientists, but there's also millions of people outside of a core data scientist role that need some kind of data literacy. And what I mean by data literacy is just a basic understanding of how to understand data, how to work with it, how to interpret results, so that way you can basically be very data driven in your decision making. So you're using AI and data science to support your decisions where otherwise you may not be able to. And as we'll see, this really does give people, and not just people, but companies and countries, an advantage in what they do. So there's so many people that need to be upskilled to partake in this data revolution. And just to drill down on that point a little bit more, Correlation One has built out a data fluency matrix. And in doing this research, we discovered that data is not a job family or a vertical. It's really a horizontal that cuts across many different roles. So, what you're seeing here is that it's not just people who are data scientists, it's people who work in product, people who work in operations, people who work in finance, people who work in marketing. And they all have some use of data within their roles that, they are not currently being able to access. And so they're not, getting the full power of AI and data science in their current jobs. So you can see here, for example, several types of roles where, the use of data science is extremely useful. For someone who works in product, how do you minimize customer churn? Knowing skills in these realms such as data interpretation, data analysis is extremely useful for that, but maybe less useful for someone in operations. And this is what we mean by data literacy, just having a familiarity with the skills within data that you need to be even more potent at your job. And so, when thinking about that, it's countries, businesses, and individuals that need to upskill urgently to be competitive within the AI economy. As this trend is taking place, there's really, three things that you need for this data revolution for data science to really take hold. And that's data, talent, and people. We already have the data, we already have the technology for people to analyze the data. What's really missing is, the people with the skills to leverage the technology and the data to get the most out of it. And so we really do need to upskill people around the world to be able to take advantage of this and get more leverage from what we're doing. And so as you can see here, this really creates this amazing opportunity that's available to all of us. And it's that AI yields a competitive edge. Companies that develop AI capabilities scale faster and create moats, and the companies that don't are going to get left behind. This is true of individuals. If you upskill yourself and are able to become data literate, you'll have an immediate advantage in the job market over someone who has not developed those skills. We can see already from our own interactions with companies that there's this broad demand for people who are data literate and have familiarity with how to use different data skills within their job. As you can see, it applies to every industry, from marketing, customer experience, logistics, security, and it really is a virtuous cycle. The more data you collect, the better you're able to predict things, and this improves the customer experience and allows you to grow faster. And from that, you're collecting more data on your customers. It's the reason that companies like Google and Facebook are able to continue to grow and be the dominant player in the market, is because they're able to access all this data and keep improving their customer experience and continue to capitalize on that. But contrasting with this opportunity, we also have the problem that companies face. And this kind of goes back to what I was talking about at the beginning, which is firms, there's this need for data talent, but firms really struggle to implement AI. And there's really three main problems that we've discovered in the time that we've been around as a company, and it's really three things. So the first thing is business executives lack data literacy. It's not just enough that there are data scientists within the company, but executives need to be able to utilize those insights, understand how to best direct their teams, and take the most advantage of what's being done within their company and make data-driven decisions. The second problem is that when there's training, sometimes it's too theoretical. Oftentimes we find that with other data science courses, you'll learn the theory of data science and statistics and machine learning, but when you leave the classroom, you really don't know how to apply what you learned. And we really need to tie education closer to the business needs. Lastly is what I mentioned before, is hiring external AI talent is hard. There's really a scarcity of talent compared to the vast demand, and the demand is only growing as AI and data science continues to grow as an industry and as a profession. So, supply of data talent is not keeping up with demand. So that's, kind of why data science is important. We really are at the beginning of a data revolution. I know, now we see the words data science and AI getting thrown around a lot, but we really are at the beginning, and it's only going to continue to grow from here. And so, with that in mind, all of that's really the foundation for why Correlation One exists as a company. The most sophisticated firms in the world trust us to help them with their data science talent problems. And we focus on three main areas within the data science talent ecosystem, which is A, training, B, helping to assess talent, so helping companies decide which employees they should hire within their data roles, and then talent acquisition, so helping companies find talent that's either underrepresented, hard to find, or just generally hard to identify. And from this, we've built this massive network. We have over 50 data roles, which we have field tested intellectual property for, over 500 data organization partnerships, and this large community of over 250,000 data scientists who contribute to our curriculum, our assessments, and our content. And from that, you can see that we have lots of clients, some of the world's top firms who trust us, within this domain, which is companies like SoftBank, Johnson & Johnson, Bloomberg, and many more that aren't this list. Of course, the Government of Colombia, we work with closely on the Data Science for All program, and it's a partnership we're proud of. And as you can see, we do training programs and competitions around the world. We've run competitions in China, London, South America, the United States, and through that, we've developed this massive community of data scientists that is only going to continue to grow. And obviously, like, one of our keystone programs, and honestly one of our favorite programs, is the program we developed in partnership with Mintique, which was really this program to help Colombia and Mintique develop their AI ecosystem and really become the Silicon Valley of Latin America. And so as you can see, Mintique came to us with the goal of training citizens for the jobs of the future. And more than that, not just training citizens, but reaching underserved areas and reaching people that may not have access to this training otherwise. And it's not just about conducting the training, but also partner with local employers and partner with local universities as well. We've managed to partner with 5 universities so far, including Union Norte, to help expand the impact of what we're doing. In addition to that goal, obviously that's always paired with a problem, which is bridging the skills gap that they encountered locally. And so obviously Colombia has this great STEM educated population, but oftentimes what we see within data science is the AI education opportunities are lacking. And a lot of companies want to take advantage of training the personnel in data science and leverage that for their own companies to get that competitive advantage that was mentioned before, but they don't have the ability to do so, or maybe the resources. And so from that, we worked with them to develop our 2019 pilot program, which has expanded since then, and I'll get into that in a little bit. But we have an elite instructor team. It's led by Professor Nitesh Pillai of Harvard University. He's a tenured member of the faculty there in the statistics department. Our curriculum and project work are all based on practical, real data sets. We focus on job-ready training so people feel comfortable, applying what they learn and joining a data job after they finish graduating. And then more than that, we took it one step further and said, let's connect our graduates with jobs, because ultimately, that's the impact that matters, is meeting the supply need within the data talent ecosystem with meeting the demand with the supply. And so we managed to have a career fair with over 100 companies. And I'd like to get a little bit more into the program and how we've been able to create this impact, because really there are a lot of people out there trying to create a data talent ecosystem, and we think we found a formula that really involves all the key stakeholders and really is a tide that lifts all boats, and is extremely effective in developing the ecosystem. So we've determined, these are the core pillars of the success of DS4A, and not just DS4A Colombia, but our other programs around the world. And it's really about bringing all the stakeholders within the ecosystem together and making sure everyone benefits and is working to help each other. So obviously, the cornerstone of the program is world-class instructors. You can't have a great data science training program without great teachers. And we've been able to do that obviously with Professor Pillai, but with TAs from other top universities in the United States that we brought in. But what's even more is we've brought in rather TAs that are former graduates from the program, and helping foster the ecosystem that way, where former graduates are giving back and helping to foster the ecosystem they were part of to create that continuity. We also do it in a live online format. So this is synchronous learning. We have lecture all at the same time. Everyone comes together at once to get the benefits of in-person learning, while at the same time making it accessible to people across the country. Before when we ran the pilot program, it was just in 4 cities in Colombia, and it was done in person. But when we expanded it to be online due to COVID, what we discovered is that we're able to access people in underserved areas across the country, which is a really powerful thing. Before, you need to have critical mass in a city to be able to serve everyone. Because if you only have a city of 5, 10, even 50,000 people, that's not enough to bring a data science program to there in person. But now all you need is internet access and a computer to access the training program. It doesn't matter if you're in Medellin or a smaller city in a rural area. And it's really about creating access to everyone that merits it and wants to be part of this revolution. That's really the important thing. Obviously, I mentioned our university partnerships, such as with UniNorte. We think this is extremely powerful because we're able to continue to spread the AI knowledge that way. Professors are able to enroll in our program and take this knowledge with them to their classrooms, and spread it within their domain to their students, whether it's within data science or something else, and using data science to learn, for example, something like biology or business or marketing, something like that. And that way, we're able to expand the impact of the program. A key part for us is high impact projects. We involve public and private entities that submit projects to our program, and the students work on those projects to solve them, but also apply what they learn. So it creates this dual impact for both the students as well as the companies and public entities who get their problem solved using AI and data science. And then last but not least, the career fair helps us connect people who want jobs and now have this data training with employment opportunities. We've seen from all of our career fairs that there's this giant need for data roles, and there aren't enough people right now to fill them. And we help to make those connections to make that last mile connection between education and training with impact and jobs. And one point I'd like to dive deeper on is the projects we've been able to do. We've had impressive results with what the students have been able to do. We put our students in teams of about 5 to 7 people, and they work together to apply what they learn in the program to a real project. And some of these they come up with themselves, as you can see on the right, from the custom projects to some on the left, where we host a convocatoria for public entities and also private companies to send projects and say, this is my problem. Can you help me solve this using data science? And our teams use these real data sets to apply what they learn and solve the issue. So the entities get this custom solution for them completely for free, and then the students get this free real world, almost an internship solving this problem. So when they finish, they are now ready to do the same thing in their next role. So we have these amazing projects, such as one for the Agencia de Desarrollo Rural, which was how to prioritize funding for agricultural projects. Another one that was amazing was the improvement of criminal policy to lower the recidivism rate from El Ministerio de Justicia y del Derecho. And then on the right, you can see there's a project working on indoor monitoring using computer vision to help manage social distancing for COVID, but also with business applications as well. And on the bottom right, one of my favorite projects is the mapping of coverage of hospitals in Cali to guide the construction of new hospitals. One thing they were able to do here was to basically predict the traffic using Google Maps data, and from that understand how long it took people to reach hospitals in the case of something like a heart attack, where time really matters. And from there, they were able to see what areas are being covered and what areas are not, and then from there suggest where to build new hospitals to increase the coverage of the city, especially for underrepresented populations. So as you can see, all these projects, not only are they interesting in themselves, but have amazing impact for their stakeholders. And so with all of that in mind, DS4A Colombia really seeks to create an ecosystem. We want to be more than just a training program. There are lots of boot camps out there teaching data science and other things, but what they're not doing is building an ecosystem around the program. And for us, it's really about four main things here, as you can see, and they all build on each other. There's data science education for individuals, giving people the skills that they need to be able to get the jobs that they want. We've had plenty of stories of people who were stuck in a certain profession and didn't know how to advance to a job they wanted. After going through the program, it was life-changing for them, and they're able to move on to another role that empowered them, not just from an interest in the work they're doing, but also in they're able to increase their pay as well. Like I mentioned, solving important public sector issues with the projects that we do, driving private sector growth as well through the projects, and connecting companies with career fair graduates. One of the other things we've seen as well is graduates have been able to create startups out of the program, either through their project or also just from an idea they had before, but they were able to get credibility from graduating from the program and get funding that way. And last but not least, universities are a key part of this. We help train professors as part of the program, and they get access to the curriculum as well. And they also get access to the top talent in the program as well that can continue their education at their universities. And bring it all together and really showing the numbers of the impact. We've had 4 programs so far, and it's created this massive impact on a national level. We've educated over 1,700 Colombians in data science. This year we'll do at least another 500 more. We have over 65 projects from the convocatoria with the different entities across the country where they've submitted projects and created impact for them. Like I mentioned, we've partnered with 5 universities for these previous programs and trained over 50 teachers from there. And bring it all together, it really does create this one Colombian AI ecosystem that's going to continue to grow in a virtuous cycle. And we've started to see that already, and we can't wait to see as it continues to grow in the next few years, because it's really going to take an exponential curve where as we continue to put more people through the program, it will continue to build on itself and create these amazing network effects. So now that I've told you a little bit more about why does data science matter, who we are, how we're trying to solve the problem, and also the Data Science for All Colombia program and what we're doing there, I'd also like to dive into artificial intelligence and what it is, and really break it down to its core components. We see all these things in the news about what people are doing with AI, whether it's around proteins or what companies like Uber are doing. But we really want to break it down to its core steps where it becomes a lot more approachable and you can understand why it works. Obviously, we'll simplify it in ways that are understandable, but that make it more approachable as well. And so just breaking it down, what is AI? And here we've kind of broken it down into 3 concentric circles where there really are layers to it. So we'll start at the top, which is data analysis. And this kind of goes back to what we're talking about with data literacy, where you're really using data to help and data techniques to help understand all this information that you have in front of you to create additional impact. So you have things like visualizations, dashboards, summary statistics, cohort analysis, just taking summaries of the data and conveying it in certain ways so that's more easy to understand, and you can get conclusions out of it where you weren't able to before by just looking at the numbers and the data. Then diving another layer down, you have data science, and that's where you get into more modeling, where you have people applying linear models, trying to do some more prediction in terms of the data that's available. And drilling down one more step, there's obviously artificial intelligence, which is taking it one step farther. Things like machine learning, where you're building algorithms and using algorithms to better understand the data in more automated ways. And so if you look at all these things, the unifying principle around artificial intelligence and data science is really just prediction. It's all it is. It's just a simple tool for prediction. So when you think about something like loan applications and trying to figure out who's going to repay those loans, it's really about predicting who will repay. When you think about product recommendations, it's really about predicting what someone wants to buy, because you're saying, okay, this is a product they've already bought, and I'm going to use that to predict what they're going to buy and suggest that to them. We see this on websites like Amazon all the time. Same thing with text translation. You're trying to analyze words to try to predict what that word corresponds to, whether it's a sentiment or something else. You're trying to understand, okay, using this word, I'm predicting what emotion it corresponds to better understand the person who's writing it. And then there's things like computer vision, where you're trying to predict what objects you're seeing. There's the classical example of taking different pictures and identifying which one have, for example, an animal like a cat. You're trying to predict which one is a cat, which one is not. And so when you break it down into its core component, prediction is something very simple. You're trying to take data you already have and trying to make a prediction on what something is. So this is your classic XY variables, something as simple as weight and height. If you take, as you can see here, you have a table of people with different weights, different heights. And then, from there, you're able to see, the basic distribution of where people break out to on, the ratio of height to weight. So from there, using this data, you're able to say, okay, I know these people before had these heights and this corresponding weight. I'm going to try and understand that relationship. And then if I meet someone new, or someone tells me, someone is 1.7 meters in height, I can better take a guess on how much they weigh. And it's something as simple as that in terms of what you're trying to accomplish with AI and data science. But we want to take it farther from just something as simple as two variables and saying like, okay, I know X and now I want Y, but obviously AI and data science is much more complicated than that. So we're going to walk through a couple mental models and kind of show the progression of how this works, and on a fundamental level, what you're trying to do with data science and AI. So something as simple as annual income, right? And what you're trying to predict here is if someone's going to repay their $10,000 loan over the course of 1 year. So imagine you are a bank, you're lending out to a bunch of people $10,000, and you're trying to see if they're going to repay you a year after you give them that loan. And so with that in mind, this is what we're trying to predict. We're trying to predict whether they repay us. And what you're trying to see here is, all right, I have a variable such as annual income, and from that, from this past data, I'm going to try and see what the relationship is. So as you can see here, we have 3 people, two repaid, 1 did not, and you can see here that 2 people had high income over 40,000 US dollars, and 1 had very low income, and that person did not repay. So just from simpler intuition, not even using computers, you're able to say, okay, someone who has lower income will be less likely to repay, and you're able to understand that relationship. Now you add in another variable. You say, okay, not only do I have annual income, but I have debt and assets. So I'm able to see, okay, someone has no debt, little assets, or may have a lot of assets and a lot of debt. And from there, you're able to see, okay, people with more debt are less likely to repay, and people with more assets are more likely to repay. So you can't understand, the exact relationship, but you understand directionally which, how it affects the outcome that you're trying to predict. So it's still intuitive. But then we get into more complicated things, right? So we start looking at, for example, text. Someone is filling out a form for the loan, and they say, they tell you why they need the loan, and you're trying to predict from that why, if they're going to repay. And so this becomes more complicated because it's less easy to see and trying to identify, how it's going to affect the outcome. And so for things like this, maybe with a few applications you can do it with just by reading, but obviously with many it's hard to really determine relationships. So you need things like NLP to parse the text and categorize it to better understand it and gain a relationship, or understand the relationship between the reason for loan and whether they'll repay or not. And then adding, another factor, for example, their website activity, seeing what they do on your website app, for example, when they're applying for the loan. And from that, it becomes even harder for a human to identify how that affects their ability to repay at all. And you need something, like front-end engineering to capture it, parse it, and obviously the data science to analyze it. But just from the human perspective, you're unable to see how these numbers affect the ultimate outcome of their ability to repay. And then from there, you take it one step farther, where it's not just a few variables, but tons and tons of variables, and you're trying to see where intuition at that point stops being as useful, because there's the human mind doesn't work that way. And so you really need machine learning and AI to fully understand the relationship and how to correctly apply it. And what's even more is when you have not just a few data points, but a lot of data points, it becomes much harder for a human to be able to understand that. And so as you can see here, bringing it all together, you have all these different variables, all these different relationships, and you have the different outcomes. But obviously the thing with data science and with prediction is you have to use the data to predict the future. You're using past outcomes to predict future outcomes. And as it says on the slide here, life can only be understood backwards, but it must be lived forward. So you're trying to use what happened in the past to try and understand the future and try and predict it that way. But obviously there are changing relationships even using the data that you had. So that kind of breaks down the basics of what AI is and why it's kind of necessary to go beyond just basic understanding of variables of something a human can see to something that's much more complex. You're able to gain so many more insights using data science, machine learning than you would just with human intuition. It's not to say that human intuition is not useful. It is, but we have to understand where data science is a tool, and we have to understand where the tool is useful and where it is not. And so, diving into that a little bit more, we have to understand the problems we can solve with AI. And there really are a lot of applications. So, we have things like optimization. So predicting package arrivals and driver availability to optimize delivery routes. These are things that, things like Uber use, companies like Rappi or Logi, where they're trying to find the best routes to places to minimize the cost and time used by their resources. Things like forecasting. The loan repayment example we just used is a perfect example of that. And you can go beyond things like just income and assets and try and find other data points that are good predictors of repayment, but weren't used in the past because using traditional methods, they kind of escaped a traditional matrix that has been used by banks in the past. Things like anomaly detection. You're trying to find things that stand out. For example, you flag anomalous package delivery behavior to detect delayed delivery potential and trying to find those instances. Another example is clustering. You're trying to predict revenue per room for a hospitality company. And the basic problem there is expected revenue for the core economic unit. Pricing is another great example. You're trying to predict the user's demand function with sensitivity to competitive dynamics, margin goals, supply. So better inform your pricing model using all the data available. And beyond just the normal pricing, there's market making as well. Trying to match and demand and supply, and more than that, trying to predict it so you can match it better in the future. Entity extraction is another example. And lastly, recommendation. Trying to predict what a user will buy based on their history and company overstock. If you have something like an Amazon account and you buy a bunch of stuff, you'll see when you log back in, they give you some recommendations based off of that on things you should buy, because they say, okay, people who have bought this in the past also bought these things, so likely this person will likely want to buy these things, or at least will be more likely than just a random product. But in addition to understanding the problems you can solve with AI, we also have to understand what we can't solve with AI. Like I mentioned before, AI and data science is a tool like anything else, and you have to understand, where it's appropriate to use, the tool and where it's not. So, it's extremely useful in some contexts, but we have to understand the limitations to apply it correctly. So here are three, key places where we find that it has limits. So an unstable environment, prediction becomes harder when the underlying data keeps changing. So like I mentioned before, you're using historical data to predict the future. But if the situation or the environment changes, then the past data is no longer relevant because it doesn't reflect, the relationships that are currently occurring right now and that will occur in the future. So at that point, even worse than not being useful, it'll give you the wrong predictions because the relationships have changed. Another good example is, when there are a few historical examples, something like a black swan event. These are things that are super, super rare and don't happen very often, to the point where it's hard to understand the exact probability of their happening. So because they're so rare, it's hard to predict when the next one will occur. And last but not least is when there's little data. Models are only as good as the data they're built on. And one of the key lessons about data science is that the data is sometimes even more important than the model. It's like building a building on a weak foundation. If the foundation is weak, then the building will be as weak, and the flaws will be reflected in the end product. So it's important that your inputs be, not only that you have very high quality inputs, but that you have enough where you're able to actually be confident in the, that it's reflecting the actual relationships that you're seeing and making accurate predictions. And so in these situations, the purpose of using data science is not to, automate decisions, but rather to, support those decisions. And trying to find ways to, inform your decision making, but you can't rely on them completely to try and automate how they run. And so just to kind of wrap it up and bring it all together, data-driven decision making is something that's going to be increasingly important as we move forward into this century. And one of the big misconceptions we see about AI is that it's going to replace a lot of jobs. And there will be some jobs that get replaced, the same way that factories replace some jobs because of the efficiency gains in labor. AI will have some similar gains as well. But what's more than that is that it also, create jobs and enable people in their current jobs. We saw the same thing with past technologies, and we'll say the same thing here. But the important thing for AI is that's going to enhance human decision making. It's going to affect the jobs that are left, or all the jobs that remain, which will be the vast majority, and they're not going to really replace them entirely. We're not going away soon. We still need humans to do a lot of the work. And so the important things are to really understand why models are useful, and it's because they help you trade off information consistently, and they keep you away from emotion-driven anchoring. We want to use the data to really drive our analysis rather than using our own emotions and intuition, which oftentimes can be misguided. So using it as a sanity check. In addition to that, humans can incorporate all sorts of information and generate patterns from very little data. Going back to the example of identifying pictures of animals, right? You as a human, it's very easy for you to see if a picture has a cat or not. That's why when you do the you see that question on when you're paying something online and asks you to identify all the animals or the traffic lights. And then you as a human are able to do that much better than a computer, and it's very intuitive for you. And we have to understand where those situations are and how to best utilize human judgment versus using a computer and AI. And it's important to leverage the power of AI without succumbing to it and to the cognitive biases. And so we're able to use this power to kind of overcome the deficiencies that we sometimes see in human reasoning to really become much more powerful in our decision making. And so if you combine human thinking with the tool and analysis of data science and AI, you're really able to have this synergistic effect where you get the best of both worlds and really come out with the best outcomes. And so just to summarize all that, it's really about calculating like a machine, but imagining like a human. There are limitations to what we can do with computer science, AI, data science, and we really have to rely on the human side of things for many things, and we'll continue to do so into the future. And so with that, I'll wrap it up. And again, thank you to everyone for attending this talk today. Thank you again to Uninorte for giving us this opportunity. And would love to answer some questions about the talk and everything else. But yeah, this has been very exciting for us, and we're happy to be able to share all of this with you.
Muchas gracias. Thank you very much, Eric, for sharing all this information with us. We have some time for questions. So, para todos los que nos escuchan, si tienen alguna pregunta, pueden hacerla a través del chat. Vamos a comenzar con la primera pregunta por parte de Natica21. ¿Conoce alguna implementación de inteligencia artificial en la toma de decisiones del gobierno colombiano?
Yeah, so we actually do, and there's actually a lot of projects that came through our Data Science for All program that were submitted by governmental agencies. One of the examples was the one that I put up there about the Agencia de Desarrollo Rural, where they're trying to best predict how to use their funding for the projects and whether to approve projects. We saw that I think several of our graduates from our first program went on to help the government with the COVID response after the fact, and even something as simple as helping to identify delinquent people who are delinquent on their taxes and not paying their taxes, to identify those cases, to find out who is not doing it, and helping to implement that policy to make sure that everyone pays their fair share. So there are tons of examples that we saw even through our own program. I'm sure there are many more that the government is trying to implement that are beyond what we did in the program.
Thank you very much. So we have also a question from Marta Ligia, who says, how long does it take for someone to become data literate? In addition to programs like DS4A, what other options do you recommend to get formed in AI and data analysis or data science?
Yeah, definitely. So, I think the important thing to mention is that data literacy is not a destination, right? Like with anything, it's about there's a spectrum, and there's a spectrum of where it starts becoming useful to you, and how far you want to go, right? So, in the same way, with any other skill, there's a start and a certain point where it starts becoming really useful, and obviously you can take it as far as you want to go. So over the course of another program we run over 14 weeks, our goal is to get people to a place where they're able to get the data skills they need to apply in any type of role, and so get to a basic basically the foundations of data analytics and become data literate enough to understand where to go next. So it can be as short as our 14-week program, but obviously the sky is the limit, and you can take it as far as you want.
So following that question, what would be like the requirements via data science?
The requirements to learn data science?
To become a data scientist. Like if you are already a professional,
mm-hmm.
You're already in your career and you want to switch to data science, what would you do?
Yeah, so I think that's part of the problem we're trying to solve with our Data Science for All programs, right? Is there are a lot of programs, if you as a professional, you're 5-10 years into your career and say, what I'm doing doesn't interest me as much anymore, and I want to get into data science, or even I want to learn more about data science to help me with my current job because I like my job, but I know data is going to be useful for that. So how do you do that? Well, in the past you had two options. One was go back to university, so stop your job and go full-time back to university, or do some kind of executive program, or you could go to a boot camp as well. And most of these also you have to go full-time as well. But what we try to solve with our programs is this problem of not just working professionals, but also students who say, like, I understand data is important, I want to learn more, but I don't want to stop what I'm doing now to go do that. And so what we hope to achieve is this part-time program where you do it only Fridays and Saturdays, or sometimes only Saturdays, and that's the only time you have class. Everything is done on your own. So you're able to continue doing what you're doing while at the same time, learning the skills you need. That's I think the problem, not just with data science, but it's a modern problem where we need to take education to the next level, where we see all these technologies changing. Even in the 5 years after you graduate, the technologies that people are learning and doing now wasn't something that you learned. So we need to figure out how to continually upskill workers and talent, really, so that you can stay competitive in the job market, and companies can, obviously, they benefit as well from this. So it's about, finding the programs and defining programs that help upskill people, while at the same time allowing them to continue pursuing what they're passionate about.
So thank you very much. We have another question from Ser Alvarez Uribe. It says, how do you see the future of learning assessment with the implementation of AI?
Yeah, so this is definitely a big question, and obviously it's sensitive in many natures, because one of the things that is important when thinking about data science and AI is not just using it, but using it in an ethical and a correct way. So AI is going to help us with assessments better understand people from a quantitative perspective that removes bias. One of the issues we often see with admissions processes, whether it's for a job or a university, is that there are all these factors that are tend to lend to bias that favor people, and oftentimes work against people from backgrounds that are underrepresented. So where AI comes in is to kind of level the playing field and better help institutions use data to analyze applicants. So one of the things that we do as a company is we actually have this assessment platform that we lend out and license to companies that help them hire for data-related roles. And they're able to test people just based off of their skills, nothing else. Because as we've often seen is, resumes can be misleading. Oftentimes just the formatting can throw someone off, and there's so much bias that can even creep in just by looking at someone's resume. But when you test someone's skills, you're able to say, okay, like I know this person is good at X, but they're not good at Y. And they have, these skills, and you match that to the job you're trying to hire for. And from there, you're better able to understand, who's really a good candidate. So it's methods like that where we're able to use AI to better predict who's going to be a better candidate, right? Because then you're able to aggregate all the data you've used in the past, and this is what we've done. We've tested, thousands and thousands of people around the world, and you're able to create a benchmark and then make a prediction on somebody based off of your past data.
That's very cool. Actually, when you talk about the resume, the curriculum vitae, that's something interesting, because now some AI algorithms are doing that selection, at least the initial selection. So it's something to take into account when you write a resume, that you need to put the right skills that the company is looking for, because it will be analyzed at the beginning by a machine.
Yeah, definitely. Because, like you're saying, they look for certain keywords, and oftentimes just having the same amount or more of that keyword. So for example, you're applying to a machine learning job, and if you put in machine learning 5 times on your resume versus someone who put 2, it'll put your resume up in the rankings. So that's also something we have to be cognizant about when using those tools, right? Because it's not just, if you can trick the tool, then it's no longer a useful tool, right? So you have to understand where it's being useful and where it's not.
Yeah, but still it's good to know. Maybe if you're not applying for an AI work job, if you know that how those algorithms work, maybe you can create a better resume.
Yeah, definitely. It's a good suggestion.
So this is a question from Jair Payares. It says, ¿qué recomendación se les puede hacer a las pequeñas empresas para que implementen ciencia de datos?
So it's this is a good question, because I think oftentimes the issue is you see big firms have the resources to hire lots of people and build out data science teams, but obviously with smaller firms with limited resources, you have to figure out, okay, I know AI and data science is a thing now, I know it's useful, but I don't know how to implement it with the resources I have. And so you have to, find ways to implement it in an intelligent way within the, the framework that you have. And I think it comes down to basically understanding the problems that you have, right? So, making sure, one of the things that we do when we help companies submit their projects to our program is help them identify, like, what is a data science problem? And like I mentioned, it's really about understanding what you're trying to predict. So for you, it's the same thing as looking at your company and using the framework that we went through in the presentation, saying, okay, what am I trying to predict, in my company, and where would a data scientist be useful in doing that? So applying those technologies to the highest leverage problems that you have. So for one company that we worked with before, they are a fintech company. They give loans out to people, and one of the problems they have is just analyzing the submissions that they get. Previously, it was a very manual process, but using data science and machine learning tools, they're able to save like 20 employees worth of work just by implementing that system. They used NLP to be able to read all of the all of the applications, since it was submitted like a paper format, and then from there they're able to upload it digitally and then make different predictions based off of that. So it's really like understanding the the highest leverage problem you have, and then you can obviously hire a data scientist and apply them to that problem. But one important thing to always note is that you want to make sure that you pair people who work in data scientists with the domain experts, because data science is not useful in a vacuum. You need to understand the underlying data and the problem that you're trying to solve.
Thank you very much for the answer. So we have here a lot of questions now. We have one question from Sisa. What is the most important thing to start as a programmer in artificial intelligence?
Yeah, so it's a great question, and I think obviously the foundational skills and the technologies are like the best way to start. We teach Python as the main tool in our data science for all programs, and obviously you can do things in R and other languages, but for us that's how we decide to teach it. So just starting with one of those things and understanding how to best use it is, I think, the best place to start with. Just starting with the basic technologies and skills, and then working up to the more complicated applications.
Yeah, I think that leads to a question from Karen, which says, what are the 3 top skills as data scientists then?
Definitely. So, I'm sure a lot of people have different answers for this, but obviously, if I had to pick 3, obviously there's the technical understanding of things. So, I think it's data science kind of crosses, 2, probably 3 different domains. There's obviously the programming side, the computer science side, where you actually have to use the tools to do what you're trying to do. This is like the hard skills side. There's the statistics side of things, where you actually have to understand how to get conclusions and valuable insights from the data. And statistics is the main tool to be doing it that way. And then last but definitely not least is communication. One of the things that we really try to emphasize in our program is the power of communication and impact. If you as a data scientist, and honestly this applies outside of the realm of data science, if you aren't able to communicate what it is you've gotten a result, it doesn't matter what the outcome is, because no one's going to understand what you're trying to do. And so this is especially true if you're trying to communicate with a technical or non-technical audience. So if you are a data scientist in a company trying to work on a problem for the sales team, but they don't have as much experience in this realm, if you can't break it down to things that are useful for them, they're not going to see your work as valuable. So that's, I think, a very important thing, is to make sure you're always focusing on impact and not necessarily the tools you're using.
Yeah, that's a very good point. Actually, it comes to data literacy as well, because business people like managers and directors, usually they don't understand what is data science, and it is very important to communicate in a very good way. And actually, sometimes they don't want to go into data science, because they say, why I'm going to do something in a different way if right now it's working with the usual ways to do. to do it. So what would you say about it? How would you educate business people, like the ones that are in the top, that are going to make the decisions?
Definitely. So, I think when you approach business executives, I think in some ways, they have a point in saying like, why do I spend my time doing this? This is not what I do. And it's not about teaching them everything about data science. It's about teaching them, what's useful to them and what's helpful for them to understand what your work is as a data scientist, right? So how do I best use data-driven decision making, and how do I ask the right questions? So it's just about explaining different, concepts to them so that they can understand. And so when you're approaching, an executive with what you've done, not focusing on the intricacies of what you've done with your modeling and the data cleaning, but saying, we analyzed this data, and through that we were able to understand this, and we didn't understand that before. And using this information, we can, take action X, and using action X will actually save us a lot of money because, we figured out how to do it in a better way. And from there, you're able to show, okay, this is actually a very useful tool. And now your manager says, okay, now that I've seen this being useful, maybe I want to understand more. And you can continue to, expand on that. But it's really important about showing the usefulness. And, for managers who are maybe listening, just understanding the basics of, why something, understanding the conclusions that your team is bringing to you, your data science team is coming to you, so that you can understand, how that has a business impact for what you're trying to achieve.
Yeah, thank you. So here another question from Judith. She says, la ciencia de datos se aplica a todas las áreas del conocimiento y profesiones. Es transversal a muchas cosas como matemáticas, estadística, etc. ¿Por qué un profesional específico que se llame científico de datos para esto?
Yeah, it's a great question, and honestly, it may seem kind of counterintuitive. Okay, it's useful for a lot of things. So why does there need to be someone who's just a data scientist? And I think it's a great point where a lot of people, if they had the data science skills and worked in another domain, it would be extremely useful for them. So if I work in marketing and I'm trying to better understand my customers, I can take my customer data, do the analysis, do data visualizations, and maybe do some modeling to understand, okay, who's my best customer, who's spending the most money, what type of person is my ideal customer. So that's extremely useful. And it's someone whose main job isn't data science, but they use it for the role. But oftentimes, we need experts who have better understanding of the technologies and how to apply them to complement domain experts, right? So the marketing person may have a limit on their their knowledge and what's useful on their day-to-day, and the data scientists can work with them so they can work as a team to use the marketing domain knowledge as well as the data scientist knowledge from the data science person to build algorithms and better predictions together that be more powerful than either working alone.
Thank you very much. So here comes a question from Joaquin. It says, why is there a specific program for women at Correlation One?
Yeah, it's a great question. And so, I think, for us, we're really about, helping people gain access to the jobs of the future, which will revolve around data science and AI, and building these ecosystems. But one of the things that we saw as a company is there really is this issue of underrepresentation within the data science community. And this, applies to, obviously, females having fewer, less representation in the data science community compared to men, or other, minority groups, especially within the United States. We see this a lot. And we really wanted to create equal access to jobs of tomorrow. So we see, in technology more broadly, we see this issue where men dominate the space. And, the tech has been around for, over 20 years now, but it's still not in equal footing. And now that we're at the beginning of the AI revolution, it's important that we give people equal access and that we really make it an inclusive environment. Because one of the things that we see is that, in addition to it being the right thing to do, is that having diverse viewpoints helps to inform the analysis that we do. And there's actually a lot of biases that can come up by not understanding the data and how it's being collected. Because like I said, your model is only as good as your data. And if people don't understand the biases within the data or just the conclusions you're making, it's obviously a detriment to everyone. So increasing representation, inclusivity, and diversity within the data community is extremely important to us.
And following up from that, machine learning is also learning, as Eric was saying, from the data that is already available. And usually, all data, historical data, is biased towards the social behavior in those times. So it is learning these discrimination ways of thinking. So it's important that minorities are also involved in this in machine learning. And I think Correction has also some other programs that involve other minorities in data science, right?
Yeah, we do. So last year we actually launched the Data Science for All Empowerment Program, and it's focused on underrepresented groups. It's based primarily in the United States, but we've expanded it to include some people from Canada and Latin America as well. But our goal there is to go beyond, obviously, increasing representation of women within the field is important to us, but we wanted to expand that to other groups as well that may not have had a voice beforehand. So at least in the United States, we're talking about people who are Black/African American, people who are Hispanic, the LGBTQ plus community, people who are military veterans, have disabilities. And it's been extremely powerful because we've just finished the first program. And, in addition to what we're teaching, one of the most powerful things that we've heard is that just being around people who look like you, come from similar backgrounds, and understanding that it is possible to learn these things and that it's not just reserved for a certain part of the population is in itself, one of the more valuable things that we're doing with the program.
Okay. Well, we're running out of time, so thank you very much, Eric, for sharing all these insights about AI and data science in the name of the Department of Mathematics and Statistics of Universidad del Norte. We say thank you. We are very pleased to have you here. And so este es el comienzo de un ciclo de charlas sobre ciencia de datos. Los invitamos a todos para la próxima. Estén pendientes por el canal de YouTube de Uninorte Académico. Muchas gracias. Thank you very much, Eric.
Yeah, thank you, Jairo. And again, thank you to Uninorte for this. Gracias a todos. Tengan muy linda tarde y fin de semana.
Los siguientes contenidos de Uninorte.co te pueden interesar. No olvides suscribirte a nuestro canal.